KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In our last class, we start to discuss about momentum. So basically, momentum is the product of mass and velocity. So the SI unit is kg meter per second and CGS unit is gram centimeter per second. Momentum is also a vector quantity. Dimensional formula will be m power 1, L power 1, t power minus 1, t power minus 1. Okay, right. So in our last class, we also discussed some of the examples for momentum, right? So momentum has great importance in our daily life. So belongs to that, I have given some examples in last class. So we are continuing. We are in continuation with the momentum. So here also we will discuss some examples. So you please be concentrate. I will explain you clearly. Okay ma? Right. See this. Speed is another important parameter. To consider a bullet fired by a gun can easily pierce a human tissue before it stops, right? So this is like what is that? When a bullet is going to hit the human body, when a bullet is going to hit the human body, right? So this is the situation. So you please try to understand the main concept involved in this example, right? So the major things. So those are dependent and independent factors of momentum, right? See here. Speed is another important parameter. To consider a bullet fired by a gun can easily pierce human tissue before it stops, resulting in casualty. So casually. The same bullet fired with moderate speed will not cause much damage. Thus, for a given mass, the greater the speed, the greater is the opposing force. For the given mass, the greater the speed, the greater is the opposing force needed to stop the body in a certain time. Taken together, the product of mass and velocity, that is momentum, is evidently a relative variable of motion. Okay, right. So these lines you please be concentrate here itself, right? It's okay. So what he told here is, right? So when a bullet fired by a gun can easily pierce into a human tissue before it stops. Okay. Suppose if the speed is less, with moderate speed, then it cause less damage. Okay. It cannot cause much damage, or it may cause less damage. Okay. So from this example, what is the conclusion? For a given mass, if the speed is more, if it is greater, so the greater the speed, the greater is the opposing force needed to stop the body, right? So if the speed of the bullet is greater, then greater opposing force needed for the body to stop the bullet, in certain time, okay, right? Suppose if you have taken together the product of mass and velocity, that is momentum, is evidently a relative variable of motion. Okay, right. So simply he is saying momentum is evidently a relative variable of motion. Okay, right. The greater the change in momentum, the greater the change in the momentum in a given time, the greater is the force that needs to be applied. The greater the change in momentum in a given time, the greater is the force that needs to be applied in case of this particular example, right? So here we are getting valuable information. So what is that valuable information means? If the speed of the bullet is greater, the greater opposing force is required for a body to stop the bullet in a given or in certain interval of time. Okay. Next, momentum is evidently a relative variable of motion. Next, the greater the change in momentum in a given time, the greater is the force needs to be applied. Okay, right. So these are the major points we got in this example, that is the action, like an action between a bullet and a human body. Okay, right. Next, I am going another example, that is, look at here, a seasoned cricketer, otherwise you can assume like a good player, right? A good player, right? So a seasoned cricketer catches a cricket ball coming with greater speed for more easily than a new player. A seasoned cricketer catches a cricket ball coming in with great speed for more easily than a new player. Who can hurt his hands in the action? So what I am saying from these three lines is, a good player catches the cricket ball and new player also catches the cricket ball, but in case of new player there is a chance to hurt his hand. So hurt means here damage, there may be a damage for his hands. So for his hands means here his means new player while catching the ball, right? So what is the reason that we will discuss now? One reason is that the cricketer allows a longer time. So here cricketer means good player. One reason is that cricketer allows a longer time for his hands to stop the ball. As we may observe, he pulls his hands backward while catching the ball. Otherwise, to stop the ball instantly, he need to apply greater force. So whoever he may be, when somebody is catching a cricket ball, after catching the ball, immediately they are pulling the ball backwards. So why they are doing so? So observe carefully. So he is increasing the time. So with how much force the ball is coming to incident on the hands of the player, it is mass of the ball, product of mass of the ball and speed of the ball. But F is equal to mv by t, that I will explain you next, because that is our topic, Newton's second law of motion. Till that you just remember F is equal to m into v by t. So here while catching a cricket ball, whenever he increases the time of catching a ball, so after catching the ball, immediately he is pulling the hands backwards. So meanwhile he is increasing the time. When he will increase the time, right? So the damage which should takes place, his hands will decrease. The intensity of the damage will be decreased. At the same time, suppose if he is not pulling the hands backwards, means he need to apply greater force to catch the same ball. He needs to apply greater force, right? So which hurts the cricketer? So why the damage takes place? When he will not pull the hands backwards just while catching a ball. The reason is greater force. Right? Next. So in this example, in this example, you can conclude one important point. What is the important point? See this. Force does not depend on the change in momentum. Force does not depend on the change in momentum, right? But also how fast the change in momentum. How fast the change in momentum takes place. So here it is the time factor. How fast the change in momentum takes place means it is a time factor. So while catching a cricket ball, right? So the player intention is to stop the motion of the ball. But to stop the motion of the ball, how much time he is taking is also matter. Suppose if he is taking less time, what happens? If he is taking more time, what happens? Right? So the conclusion from this discussion is, right, the force depends upon how fast the change in momentum also. How fast the change in momentum also. Okay, right. Next. So observations. So whatever we observed here, observations confirmed that the product of mass and velocity. Observations confirm that the product of mass and velocity is basic to the effect of force on motion. Effect of force on motion. So product of mass and velocity means what ma? Is a momentum. So momentum is very basic to the effect of force of motion. Then time also come into the picture that we discussed already. So momentum and here next thing is time. Okay, right. So the next thing is afterwards, suppose a fixed force is applied for a certain interval of time on two bodies of different masses. Suppose a fixed force is applied for a certain interval of time on two bodies of different masses. So here he is going for another example. Suppose a fixed force is applied for a certain interval of time on two bodies of different masses, initially at rest. So both the masses are at rest initially. Now he is going to apply fixed amount of force for certain interval of time. Then what will happen? Lighter body picks up a greater speed. Lighter body picks up a greater speed that the heavier body than the heavier body, right? So here I told you in this example, two bodies of different masses. So one body is lighter mass, another one is heavier in mass, right? So even though you apply fixed force, so same amount of force on both the bodies, but the lighter body acquires greater speed, but heavier body acquires less amount of speed. So that he is saying the lighter body picks up a greater speed than the heavier body. Okay, right, full stop. However, at the end of the time interval, observations show that each body acquires the same momentum. However, at the end of the time interval, okay, observations shows that each body acquires same momentum, right? Each body has different velocity, each body has different mass. Next, lighter massive body moving with greater speed, heavier massive body is moving with less speed. But when you go for calculating momentum, we are taking the product of mass and velocity. That is the reason here at the ending both lighter body and heavier body having same momentum, right? Next, here thus the same force for the same time causes the same change in momentum for different bodies, right? So here we apply same force, same time also causes same change in momentum for different bodies, right? So it is very important point Same force, same time causes same change in momentum for different bodies. So this is the point which is basic to the Newton's second law of motion. This is the crucial clue for second law of motion, right? Okay, see this. I am going for next. Direction of momentum and change in momentum. Direction of momentum and direction of change in momentum is not same in all the cases, right? Direction of momentum and change in momentum is not same in all the cases. For example, when a body is rotated in a uniform, when a body is rotated in circular motion, so basically rotated means we have to consider rotational motion. The basic difference between rotational motion and circular motion is, in case of rotational motion, we need to consider the axis of rotation also. Axis of rotation also. Okay, right. Suppose a stone is rotated with uniform speed in a horizontal plane by means of a string. By means of a string, magnitude of momentum is fixed, but its direction changes. I will repeat once again the same example, because here we are talking about the direction of momentum, because momentum is a vector quantity, no? So in the yesterday class and even today class also, while before starting the class I repeated that word. Momentum is a vector quantity which has both magnitude and direction, as well as it also satisfies the laws of vector addition like triangle law and polygon law. Okay, right. So here a stone is rotated. When a stone is rotated with uniform speed in a horizontal plane, by means of a string, magnitude of momentum is fixed, but its direction changes. Magnitude of momentum is fixed because here he mentioned uniform speed. Mass is same. Mass in this example, mass is same, speed is also constant, then magnitude of momentum is fixed, but its direction changes. Its direction changes continuously. Next, here next point related to the topic only. Next point, greater force is needed, greater force is required, greater force is needed to rotate at greater speed. Greater force is needed to rotate at greater speed for stone or in a small radius or both. Okay, so here I have written clearly, F is equal to mv by t, F is equal to mv square by r. So see this, right? So greater speed requires greater force. At the same time, what is that? Circle of small radius, or both, whatever it may be, right? So you can write it as F is equal to mv by t. You can also write it as F is equal to mv square by r, right? So the things which are present in the expression are going to change, but finally we are getting force only. So based on these two relations, we are saying this sentence is very, very important. Okay, right. Next, greater the rate of change in momentum vector, greater the rate of change in momentum vector, greater is the force applied. Greater is the force applied. Greater the rate of change in momentum vector, greater is the force applied. Okay, right. Now we are going to discuss Newton's second law of motion, right? So what is Newton's second law of motion? Here, the rate of change of momentum of a body, is directly proportional to the applied force and takes place in the direction in which the force acts. So here he is talking about magnitude of force, magnitude of applied force and direction also, right? Because force is a vector quantity, no? Right. So the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. Okay, right. Next, under the action of force capital F, for time interval delta t, Just imagine one situation to solve or to derive an expression for force mathematically. Under the action of force capital F for time interval delta t, if the velocity of a body of mass m changes from v to v plus del v, v to v plus delta v, right? So initially it is v, afterwards v plus delta v, right? So delta v is the change in velocity, then finally change in momentum is equal to mass into change in velocity, right? Because here mass is a scalar quantity, v is the velocity, I mean delta v is the change in velocity, right? So change in momentum is equal to mass into change in velocity. Delta p is equal to m into delta v. Okay, right. Next, second law here. So according to Newton's second law of motion, right, from this statement, it is the theoretical statement, so from this statement we are writing F is directly proportional to delta p by delta t, or F is equal to k into delta p by delta t. So here k is the constant of proportionality, constant of proportionality. Okay, right. Next, for a body of fixed mass, so here mass is fixed. For a body of fixed mass, dp by dt is equal to d by dt of mv, that is equal to m into dv by dt, that is equal to ma, because you know very well acceleration is the rate of change of velocity. Acceleration is the rate of change of velocity. Okay, so that you can write all these things, I mean from here to there. So including this proportional constant, you can write F is equal to k into ma. Suppose here F is equal to, already we know dp by dt, no, dp by dt, right? So here dp by dt is equal to ma if k is equal to 1, if k is equal to 1. Okay, right. Here we are giving, I'm giving some information about force, right? So the SI unit of force is Newton, CGS unit of force is dimensional formula of force is m power 1, L power 1, T power minus 2. Force is a vector quantity. It has magnitude as well as direction and also obeys the laws of vector addition. Laws of vector addition. Okay, right. So now we are going to discuss about some important points regarding this second law of motion, Newton's second law of motion, right? Okay. In Newton's second law of motion, suppose if you write F is equal to 0, what happens to the acceleration? Suppose if you have written F is equal to 0, what happens to the acceleration? Acceleration is also 0, no? So what the first law is saying, Newton's first law is saying. So in our last class we discussed Newton's first law of motion. So a body, every body continues to be in the, what is Newton's first law of motion, ma? Every body continues its state of rest or of uniform motion unless some external force applied on it. So when F is equal to 0, automatically A is equal to 0. So it indicates the situation from Newton's first law of motion, otherwise belongs to Newton's first law of motion. Okay, right. From this thing, dp by dt is equal to ma. If you apply for 3 dimensions, right? So in the last chapter we discussed motion in a plane. So what is the x dimension, y dimension, z dimension? So if you have written this all the things, I mean dp by dt is equal to ma for 3 dimensions, you can write like this: dpx by dt is equal to max, that is called as fx, similarly y, similarly z, right? So these things helps us when we are going to talk about force in 3 dimensions, force in 2 dimensions and force in 3 dimensions. Okay, right. I will give you one example also where all these things, this x, y and z helps us. I will give you one example, right? See this. In the motion of a projectile, under the vertical gravitational force, the horizontal component of velocity remains unchanged. In the motion of a projectile under the vertical gravitational force, right? So in the last chapter we discussed projectile motion. In the last chapter we discussed projectile motion. That only I am repeating again here, which is the example where we need to discuss the force in 3 dimensions, right? See here, in the motion of a projectile under the vertical gravitational force, the horizontal component of velocity remains unchanged. Okay. Next, internal forces in the system are not to be included in F. So here, when we are talking about force is acting on a body, so it is external force. It is external force. You may have one doubt, what is meant by internal force? Internal force is the force which binds the molecules of a matter, which gives the shape to the particular matter, whether it is liquid or solid or gaseous. But in our discussion here, we are taking only solid matter, right? And moreover, we are not considering the force which is the cause to bind the molecules, to make up the molecules to give a solid matter. Our discussion is not internal forces. So whatever the force we discussed till now, it is external force, right? So that's why I am saying here, internal forces in the system are not to be included in F. Force is applicable to COM, center of mass, right? You may ask one doubt here, what is COM? Center of mass, right? So if you take any object which has certain mass, right? For all these massive molecules, for all these massive particles, there is one center. There is one center. So if you apply force at that particular point, you suppose to balance the body, right? Center of mass is an imaginary point where the mass of an object supposed to concentrate. Center of mass is an imaginary point where the mass of an object supposed to concentrate. Okay, right. Next point. In case of a point in space, acceleration here and now is determined by the force. In case of a point in space, acceleration here and now is determined by the force and not by the history of motion of a particle. Okay, right. So in today's class, we discussed the example of momentum, that is bullet and human body. Next, cricketer and catching a cricket ball. So meanwhile, we got some important points that we discussed here. Next, we went to discuss Newton's second law of motion. There itself, we derived an expression for external force acting on your body, that is F is equal to dP by dt, that is equal to ma. Afterwards, we discussed some important points related to Newton's second law of motion, and then we went for some of the consequences related to Newton's second law of motion. Okay, right.